Okay, this is the Unit 5 test review. Feel free to take notes, and if you have any questions, raise your hand, and I will ask you questions, or I'll answer your questions. Okay, so the first one, there's a candle, weighs 300 grams. Each hour it's lit, it burns 4 grams of wax, right? So this is a slope of 4 grams per hour. So when you are given something that is, look at your units, right? When you're given a word problem, look at the units in your problem. Right? When it's a y equals mx plus b equation, your slope is going to be the number that has 2 units, something per something. Okay, so let's just look for that. So this is my slope of an equation, 4 grams per hour. So I'll call that my burn rate slope, M sub BR. Okay?
What is that BR stand for?
Burn rate.
But isn't the burn rate 4 grams an hour?
It is. I just named it 4 grams. I named it M sub BR so that I can use it in terms of an equation and not numbers. Okay? My 300 grams is an initial weight. Weight initial.
Teachers, please pardon the interruption.
All right, so this is the weight in grams. Okay, initially, right? And it's going to tell us, hey, let H be the hours. So H equals hours. All right, and then write an equation that can be determined to see how long it takes to the candle to burn to 206.4 grams. This is our final weight. Okay, so in a standard y equals mx plus b format, our final weight is going to be right here. It's going to be our y value. So if we had a table, we had a y value. This is going to be our grams of our candle, and this is going to be time. And our final weight's going to be, it's going to burn down to nothing. Our final weight's around here somewhere, and it's 20.6 grams, or 206.4 grams. And it starts at our initial weight of 300 grams. Okay? So what is this? What is this?
Me?
Person in front of you. I'm not going to use names when I'm recording. What is this in our equation?
The y-intercept.
It's y-intercept. So what letter is it?
Oh,
B.
B.
Right? So this is also B. All right? So let's write an equation that says, hey, my final weight is going to be equal to my initial weight, right? And then if I'm burning something, is it going to add or subtract to the weight? It's going to subtract from the weight, right? Minus, that's going to be a negative slope, right? So negative slope, oh, that's my burn rate, times the number of hours that it's got to burn. Okay, so this is the equation that I can use, right? My final weight equals my initial weight minus how much is burned. That's what this term represents. This term is how much is going to be burned during the prescribed amount of time. Okay, which is 4 hours. Right, so my equation block, final weight equals my initial weight minus my slope times my hours. Right, so look at this though, that should make sense. Right, so if I'm like, this is in what units?
That's initial.
My initial weight is in what units? It's in grams. My final weight is in grams. So what does this have to be in order for me to subtract this from that? It's got to be in grams, right? My burn rate is in grams per hour. So what do I have to multiply? The grams per hour times hours. They cancel out, and I'm left with grams. Okay, that should make pretty good sense if you use unit analysis. Unit analysis is a very powerful thing. Question.
Were you supposed to only do variable?
If you put the number in there, I gave you credit. Question.
I got kind of lost when you started writing the equation.
This.
Yeah, the one in the, I got kind of lost.
All right. So my final weight was is this many.
Yeah.
Okay. My initial weight is that much.
Yeah.
Okay. The difference is going to be how much I burn over some period of time. My burn rate times my time. So that's just how you write your equation. Okay, it's pretty simple. So if I throw in my work here, I'm like my final weight, or if I want to solve for h, okay? Everyone's like, I don't know how to rearrange equations if there's no numbers. Well, this is how you do it. Okay, I'm solving for h. Right? So I have to get my variable term by itself. What is my variable term? Here, what's my variable term? No, h is my variable. It's my slope times my slope times my h.
Is the BR the abbreviation?
BR is a superscript, or a correction, a subscript. It's just, it adds more detail to what the slope is. Because if in equations in later on, there's going to be multiple slopes. So to differentiate between them, we add BR for slope for the burn rate. Question.
How would we multiply the burn rate by hours?
Yes.
We don't know the value of hours.
That's what we're solving for. We're rearranging we know this. We know this. We know that. We don't know h. So we rearrange equations to solve for h. Right? Even if you didn't know anything, they're just like, hey, here's an equation, solve for this. You can do this just by moving variables around. Okay? So these are, how many terms are on this right side of the equation?
2.
There are 2 terms on this right side of the equation. That one and that one. Terms are separated by plus signs and minus signs. Okay? Right, so I gotta isolate the variable term. So how do I get the initial weight out of this side? Well, weight final equals weight initial minus my slope times my burn times that, right? I gotta move this over here, right? That's gonna get that out of that side. It'll put it on the other side. Technically what you're doing is you're subtracting your initial weight from both sides so that your initial weight cancels out. But if you move it to the other side, it changes sides, so it changes signs. It changes from negative, positive to negative. All right, so now I have on my left side my final weight minus my initial weight. This is a negative weight initial. Remember, the sign belongs to the variable or the term.
Wait, would it be any different if you put the WJ on the other side?
That's an I, but
I.
if you move this over here, there'd be nothing over here, right? And then you can move that over there, and that would get you the same thing. Okay, but now I have a negative burn rate. Negative burn rate times what I'm trying to solve for, again, is my h. All right, so what do I have here? I have two variables multiplied together. Okay, how do I get the h? Say it a lot. Divide both sides by the other thing you don't need. Usually this is a coefficient, right? I don't need the negative MB, or negative slope, right? So I'm going to divide both sides by the thing I don't need, or I don't want on that side. Negative that, negative that. Okay? So these, I do that so that those cancel out. The negative cancels out and the slope cancels out. So what do I have left? I have h equals this. Right? So it's going to be equal to, well, my final weight, which was 206.4, minus my initial weight of 300, I'm gonna put these inside parentheses and say, hey, they're both grams. Okay? Divided by the this is 1, right? There's nothing in that, so divided by that, divided by the slope, the negative slope. Negative 4 grams. Now if I have this per hour, another way to write this is negative 4 grams per hour. Right, so I have a fraction, a denominator on the denominator. When the denominator is on the denominator, right, think of your units like kind of like variables, okay? This goes up here, right? So this is now here, right? So now my grams cancel out, and all I have left is hours, right? So is that the unit I'm looking for the number of hours? Yes, that is the number I'm looking for. I'm looking for hours, right? So now I just got to do this divided by that. Someone do that for me on your calculators. So 206.4 minus 300 divided by negative 4. Should be around
23.4.
23.4 hours. Okay? So that is that one. All right, now Jaden has 2 jobs. 1 week, his paycheck was the same for both jobs. That's an important piece of information. Okay? So if I made a generic graph here, and I put time and the amount of dollars, right? And I do, is it gonna go up or down? The more time I make, the more dollars I make is based upon the time that I put in, right? So it's gonna start here and go up, right? So the spot that it starts over here depends upon some amount of kicker, right? Here's a kicker and here's a kicker, right? That's gonna shift where this line intercepts the y-axis at, right? That's my y-axis. That's my y-intercept, right? None of these started at 0. Right? I got tips, or I got sorry, that's the wrong one, or I get a bonus, right? So this would be your y-intercept. This is you have 2 B's, right? You have a B for a server, and you have a B for a jeweler. Okay? And this one is 82.35 for the server, and 17.10 for the sales. Okay, then that's just dollars. Okay,
What's the thing under the B?
that's a J for jeweler.
I did a J for jeweler too.
Great,
Twins.
awesome. All right, now I am going to determine how much this slope is, and that slope is determined upon, what are the units of a slope?
Units.
Something per something, right? Something per something, right? So each one of these is a 960 per hour. Hey, look, remember what slope is? It's change in y over change in x. This is my y, that's my x. This is in hours. All right, so my change in slope is my dollars per hour. So your units work out there too. All right, so for my slope for my jeweler is $14.86 per hour, and my slope for my server is $9.64 per hour. Okay, so now I have everything to make 2 equations. Right, I'm going to make one equation for my server. It's going to be blue. That equation is going to be equal the say the pay total, which is in dollars, right? It's my y. This is my x. Pay total equals, well, my slope for my, this is for server. Okay, my slope for my server. So my slope for my server times the number of hours, Okay, they say H is hours. Okay, plus whatever kicker I get. So that was plus 82.35. Okay, and then if I have for an equation for my jeweler makes 14.86 per hour, but we don't have to plug in numbers yet. It's going to be my slope of my jeweler times H plus my kicker, which is my y-intercept, which was what is it? It's 1710. 1710 in sales. This is this, and this is that. My y-intercept. Y equals mx plus b.
Wait, so, yeah, we got the stuff for the jeweler, but what about the other job? 'Cause-
Jeweler, and this is the server.
but-
So this should be S, I suppose. Yep. All right. So my pay for my jeweler, pay for my server. Okay. Question? Does that answer your question? So now I'm like, hey, the paycheck was the same for both jobs. These are the paychecks, which is, you know, the sum of my kickers and my rate times my hours. So I can say that PJ equals PS. Pay for my job was, or my pay for my jeweler was a pay for my store. If that's the same, then what can I say about these two equations? They're the same. I can set them equal to each other. So I can say my slope, my pay rate for my server plus the y-intercept for my server is going to be equal to the pay rate for my jeweler plus the kicker for my jeweler.
Is there a constant for the server?
The thing we're trying to solve for is hours, right? And hey, figure out the number of hours. Got to figure out hours here. Okay, so the first thing I need to do is step one, get the variables with my term, get my term with the variables on one side and everything else on the other, right? So this and this are on both sides. So I'm gonna move my variables left, constants right. When in doubt, do that. I'm gonna move this over here. So what happens to the sign of this when I move it to the other side? Becomes negative. It's positive here, it's going to turn negative. So, and my slope of my server times my hours minus the slope of my jeweler times the hours. And I'm going to move this one over here. Right? It's going to be equal to 1710 minus 82.35. Okay? So now, well, this is pretty easy to combine. This is dollars and dollars. So if someone do 1710 minus 82.35, it's going to give me a negative value. Some on your calculators do 1710 minus 82.35. What do I get?
Minus what?
1710 minus 82.35. Negative 65 point what? $25. Okay? Don't worry about the negative sign right now. All right, it'll probably end up working out. Right? So here I have to do this thing that we really haven't gone over too much yet. But how would I get this? What is the same thing in each one of these terms? The H. The slopes are different, but the hours are the same. All right. So I can factor out that H. It's like reverse distribution. All right, so I'm going to take each one of these H's and take it out. H equals my slope of my server minus the slope of my jeweler. Okay, because if I distributed that, what would I get? I would get this. Because the H would go to this one and it would go to that one. So now I can treat this entire binomial, the thing inside parentheses, like its own term. I can be like, hey, that's just X, right? And if I want to solve for H, what do I got to do? I got to divide both sides by the other thing I don't need. Right? I don't need this. Right? So I'm going to divide both sides by that. Right? That'll cancel that out. That puts it over there, and all I have left is H equals this. Okay? So if H equals this, right, my slope for my jeweler, or my slope for my server, excuse me, it's blue, was $9.64 per hour, and my slope for my jeweler was $14.86 per hour. When I subtract this from that, is it going to be negative or positive? It's going to be negative. That's a negative. What's a negative divided by a negative? It's positive. So positive hours makes sense. All right. So someone do, and then look at this. What did I say about things being on the bottom of a denominator?
Just combine it.
It's the same. Yep. So this could become this. Right? And if I have a denominator, in a denominator, where does that denominator go? To the top. Okay? So now these dollars are going to end up canceling out, and hours will be left. And that's it. Okay? So what is 964 minus 1486?
4.78.
Divide that. What's negative? Make it negative.
Okay.
Should be negative. Divide that by negative 62.5. It's going to give you.
62.
Yep. I divided this by that.
That's 65.
65.25.
Negative 0.076.
Now press the 1 over X button. That's going to invert it. Invert the answer.
You could do 62.
You said the 1 over x.
Here, let me see your calculator. Watch how I do this. Right? So I'm going to do this thing first, and then I'm going to do this. Right? So first thing I'm going to do is 964 minus 1486. It gives me that. Okay? Now I'm going to divide it by that, by 65.25, negative. Right? It gives me that number. Right? Well, that's the inverse of the answer, because I divided this by that. So let me push this button here, and there's my answer. 12.5 hours.
What do you mean inverted?
When you flip a fraction, you invert it.
Okay, but
But that was a decimal.
but like the correlation between 12.5.
So the answer to this is 12.5 hours. As long as I didn't get anything backwards, what I think I did.
Extra work 'cause
Okay, so here is the third one. We got Jessica and Tim want to go on a camper on vacation. The initial rental cost of the van was $185 or $83, right? So say this is the cost of the rental. All right, and included with rental is 123 miles. However, an additional 39 cents per mile beyond 120 miles is charged when they return the camper. Right. So I also got to pay for my mileage. Right. So the cost of my mileage is something else. Right. The cost of my mileage is going to be, well, I start at 120 bucks or 120 miles. I get that for free. So it's my total number of miles, right, that I drove minus the 120 that I get for free, right? And then I have to multiply that by my rate, times 0.39 dollars per mile. Okay, so that is my cost of my mileage. The total cost is going to be equal to the cost of my camper, right? The cost of my rental plus the cost of my mileage. We'll make that blue, I guess. Cost of my mileage. Does that make sense to everybody? We got the two pieces of that. So I gotta elaborate that more. I gotta expand that, and I need to substitute this in for that because there's more to it than that. Right? So this is now becomes my miles minus 120
CT.
total cost.
Wait, that's a T?
Total cost. Yes, that is a T.
I thought that was like an E.
That is a T. Okay. Minus 120 times my slope, times my mileage rate, right? Times my mileage rate. Okay. We'll call that the slope of my miles. Okay. So there's an equation that'll work. And it's like, hey, next one is they paid this much. That was my total cost. Cost total. Determine the number of miles. I'm trying to figure out this. I gotta dig that out of my equation. All right, so my total cost equals the rental cost plus times my slope plus the thing I'm trying to figure out, my miles, minus 120. Okay? So now I gotta isolate the term with my variable in it. What is the term with my variable in it? It is this one. The quantity of this times the slope. So I need to get this over here. All right? So that's a pretty easy move. Total cost minus the cost of my rental. When I move it to the side, this side is plus over here, it changes to minus over there. Right? Equals my number of miles, my slope for my miles, times m minus 120. Okay? So I'm still trying to dig out this m here. How do I get rid of this? Divide both sides by that. Divide this. Divide this. That goes away. Okay? So now I have my cost total minus the cost of the rental divided by the slope of my rental equals, I can clear the parentheses, this minus 120. How do I get the m by itself?
Divide.
Nope, this is this minus that. Add. I gotta move it to the other side. Right? I gotta add 120 to both sides. So this, when I do that, it changes sides, becomes a positive 120. So my total cost minus the cost of the rental divided by my slope plus 120 equals the number of mileage. So if I plug it in, the total cost was $598.74 minus the cost of the rental, which was $183, minus $183. Okay, that's dollars on the top I'm gonna have left over. $183 divided by the slope, my rental slope. So if I divide by something, it goes on the numerator goes on the bottom. So it was 0.39 dollars. The dollars are going to cancel out, right? And then I'm going to have out or miles on the top. Okay, so miles is left over. All right, so I'm going to take my difference of my total minus the rental cost, divide that by 0.039 or 0.39, and that is the number of miles that I travel. Oh, no, is that the number of miles we traveled?
No.
No, because I forgot to add 120 to it. Right, that's the number of miles I had to pay for. Right, I get 123 miles, so I have to add 120 to that. Right, which gives me total is 1186. 1186 miles.
Wait,
Okay, there's a lot of words here, right? Kind of skimmed over it, jumped to the back, and it says solve this equation for h. Oh, that's all I got to do? Okay. Let me solve this equation for h. I'm solving this, so I'm going to rewrite this a little bigger. T equals gx plus hy. Okay? So now, I got to do what? How many terms do I have on the right-hand side?
2,
How many terms do I need?
1,
Which one?
H.
The one with a variable term in it that I'm trying to solve for. Okay, the one with the variable I'm trying to solve for. That means I need to get this gx out of here. It's got to go to the other side. Goes to the other side, it changes signs. Right, so this is now going to be rewritten as that equals negative gx.
Wait,
No.
you have to move it to the other
Oops,
side.
you're right. That
You have
equals,
orb for that.
sure.
Yes, let's go.
Okay, good catch. All right, so now that this the t minus gx equals hy. What am I trying to solve for? H. Question.
Would it matter if it was gx minus t, negative gx minus t? Like, would that change anything about the equation?
If you move it to the other side, and then you move that over there. So if you said, if you wrote what? Tell me what to write.
Negative gx minus t.
Oh, that would matter because you change the negative from here to a positive. If you wrote negative gx plus t, it'd be okay. All right.
Okay.
Good question. All right, so now I have the t minus gx equals hy. I'm trying to solve for h, so I got to get rid of y. So these are multiplied together. I get rid of them by dividing both sides by y. If I do it to one side, I got to do it to both. Right? So therefore, my h equals that minus that divided by that. And I'm done. Okay? Questions? Here is a similar question. All right? It's solve this for d. All right, so I have to dig out d with algebra. All right, I'm going to rewrite this though to make it a little bit more easier to understand. If I have let me ask you this: if I had 2/3 x y, right? Where would the xy belong if I wanted to make this into one fraction? It would belong in the numerator, right?
Did you get
So
2/3?
I just made this up as an example for something, okay? So this is going to be 2xy over 3, okay? This is the same thing I got going on here. The only difference is I have this fraction. This is my x in my example, and this whole thing is my y in my example. Okay, because I can use a binomial that's in parentheses like a single variable. All right, so I'm going to rewrite this like 11 times, I'm trying to solve for d, times D times the quantity of F minus 13 divided by 300. Those are algebraically identical, or algebraically equivalent. Okay? So now, knowing that you have to do algebra to dig out D, what's the first thing I need to get rid of?
The parentheses.
You want to keep the parentheses.
All that.
Well, don't
How about the
you want
denominator?
to
Let's get rid of the fraction. Let's get rid of the fraction. Okay, there's two ways to do this one. Okay, I'll show you way one and way two. All right, so way one is I'm gonna multiply both sides by 300. Okay, multiply this by 300 and multiply this by 300. Okay, these 300s cancel out, so I'm left with 300F equals 11D times the quantity of F minus 13. Many people wanted to like distribute this D into that F minus 13. All that does is give you two D's, right? And it makes it harder. All right, so now I have, what's preventing D from being by itself? The 11 and the quantity of F minus 13. This is all held together with multiplication, right? So I can divide both sides by the stuff I don't need. 11 and the quantity of F minus 13. Okay, I don't want them on that side, so that's gonna cancel out the 11 and cancel out the F minus 13. But I gotta do it to this side too, right? So I'm gonna divide it by 11 and F minus 13. Okay? So, rewritten in all black. Oh, this should be blue. Okay, rewritten in all black. This is going to be 300F divided by 11 times the quantity of F minus 13 equals D. All right, that's one way to do it. Okay? Another way to do it, if you remember your rules of exponents, right? You have this F equals 11 D times quantity of F minus 13 divided by 300, right? First thing is first is let me just divide the D out right away. Okay, if I divide the D out, it's going to put it on the other side. All right, so if I divide D and I divide D, I end up with F divided by D equals 11 times the quantity of F minus 13 over 300. Okay? Now, little different situation. What I'm trying to solve for is on the denominator over here. Right? So how do I get rid of this F?
Multiply both sides.
By negative? No, that would just change the negative.
Oh yeah.
Okay?
Oh wait.
You're thinking right around the right way though. What do you think?
Multiply both sides by F.
How about I just flip this? I want a D on the top.
Yeah. Exponent.
What does that do?
If I multiplied both sides by F, I would get F squared over D.
Oh, well, what about
Right.
F?
Negative F would make it negative F over D, right? But what you're thinking, you're in the right ballpark. I want to flip it. When I flip it, what function do I need? You need an exponent, right? You raise everything to the negative 1. I'm going to raise this to the negative 1. I do it to one side, I got to do it to both sides. So now I have I have D divided by F equals 300 times 11F minus 13. Man, that was pretty handy. Okay, now how to get rid of D? Now I want to multiply both sides by F. Okay, now if I multiply both sides by F, this cancels out, and then I'm given, it goes on top over there. Right? So I have the same thing that I have over there. Okay? Two different ways to solve that problem. Well, there are probably other ones too that are similar, but a little different. But like any algebra problem, there's often many ways to find the correct answer with different solutions. So now these are starting to go by a little quicker, and it's saying, hey, there are three systems of equations. Tell me if they have one solution, no solution, or an infinite amount of solutions. Okay? One solution, if a thing has one solution, it's two lines that cross. And where they cross is the point. The point where they cross is the solution. It's going to be x comma y. Right? If I have two parallel lines, and in the equation y equals mx plus b, what is the same? It's on the board to my left. If two lines are parallel, each equation is going to have the same what? Slope. It's going to have the same slope. Okay? If by and what does the y-intercept do? It just shifts the line up and down. Right? So if an equation has the same y-intercept and the same slope and the same x value, they're the same line. So they has an infinite amount of solutions because there are an infinite amount of points on a line. Okay, so the best way to do this is kind of like just put everything in the y equals mx plus b equations and compare the y's, the x's, and the b's. All right, so I'm going to have a blue equation and I'll have a purple equation. Okay, first thing I need to do is get the y by itself. Okay, but 3 is preventing me from doing that, and so this is 12 minus 14. I'm going to get rid of parentheses first. Okay, so I'm going to leave the left alone for right now and distribute the 12 into the 4 and the negative 3. So 12 times negative 3 is negative 12x. 12 times 4 is 48. Question?
Does it matter if you have 48?
It does not.
minus 12x?
As long as the signs are the same, but traditional mx plus b form is the x first. Okay, so now I got to move this over here. All right, so it's going to y equals negative 12x, and this will become plus 3. So 48 plus 3 is what?
40 plus 3. 43.
48 plus 3 is 51. Plus 51. Okay, so now I'm going to do this one. All I have to do for this one here is distribute here and here. Okay, so I have a 3 times y equals 3 times negative 12x. Hey, what is the same in both equations? The slope. 12x is the same, right? So as long as the y-intercept's not the same, this is plus 9. Okay, so these are parallel lines, right? The yellows the oranges are the same, but these y-intercepts are different. Question?
51.
It was 48. Negative 3 moved over here, became 51. Okay? Because 12 times 4 is 48, right? Okay. All right, so now, because these have the same slope, but different y-intercepts, so the slopes equals the slope, but the b does not equal the b, right? Therefore, this has no solution because they do not intercept. The parallel lines and their parallel lines do not intercept. Okay? And there's this one. Let's put this one in a y equals mx plus b form. This one's already in y equals mx plus b, kinda. Y equals negative 2x plus 10. I just swapped the two terms. Okay? Now I'm gonna, this is in standard form. I gotta put it in y equals mx plus b form, slope intercept. All right, so I'm gonna move the x to the other side. 3y equals negative 6x plus 30. Divide both sides by 3. Y equals negative 2x plus 10. Hey, look. They're the same equation. Right? So this has an infinite amount of solutions. Same equation, same line. M equals B equals the same thing. Therefore, it has an infinite amount of solutions. Okay, now we have this one. So let me put this in terms of x, of y. I'll start with this one, right? Y equals, just got to bring the 4 to the other side, make it -4. Y equals -4x minus 16. Okay? I'm going to bring the 5 over here, bring this 5 over here, and bring the x over there. All right, so it's going to be 5x minus 2x, and then it's going to be minus 26. So 5x equals -2x plus or minus 26. Okay, so now I'm just going to, sorry, this should be a y. Okay, now divide both sides by 5. So this is going to be y equals -2/5. Are these the same slope? Are those the same slope? -4 and 2/5 are not the same slope, right? So they have only one solution. They're two different lines with two different slopes, so they intersect somewhere. Okay? All right, so here we have started working a local salon. It's in our pay rate things. Okay, there's two people. They have to work the same. They work the same to earn the same amount of money. Have to work to earn the same amount of money. Oh, determine the number of hours. All right, so we're going to solve for hours. All right, up here it says X is hours and Y is days, and they have these two equations that represent their work, their jobs, right? If you couldn't figure out one of the first like 4 questions, you could have been here and used it for a hint, right? So they were trying to save the same amount of money. Remember, money, time does that. This moves up and down based upon tips or kickers, right? So my Y values are the same. If the Y values are the same, so are the equations. Set them equal to each other. All right, so 9.85x plus 5850 equals 16.35x. I got to solve for the number hours. Hours is x. So I got to solve for x. Let me move this one over here. I'm moving it to that side because this number is bigger than that number, and that way I have a positive number when I'm done. All right, so 16.35 minus 9.85 is 650. X, 5850 equals 6.5x. Divide both sides by 6.5. So I'm going to divide 58.50 divided by 6.5 equals 9 hours. All right, that's a pretty straightforward question. Here's another one. Gives us a bunch of stuff, right? It says determine X is the number of years. We got to solve for X. All right. We have a really good candidate here for an elimination, right? Because this is double that, right? We just need to make one of them negative. All right, so I'll make the one that I have to multiply, instead of multiplying it by 2, I'm going to multiply it by -2, right? So if I multiply this by -2, I get -36x, and then minus 100y equals 176. 176 times 2 is -352. Equals -352. So that's what I'm gonna just kind of like, that is the same as that, so I'm just gonna pay attention to these two. I'm gonna combine these two together. And then I'm like, well, my negative, the y's go away, and then my x's, I'm like, wait a minute, I have a 36x and a -36x. Combined together are 0x. Whenever I solve for a value and I get 0x, the 0 variable is whatever, doesn't matter, right? That means that there are no points where these two lines intersect. 0 values of x equal anything, right? That means that there's no solution. These are parallel lines. right? So this means equals whatever. 0x means no solution. And if you solve for x, if you put these in terms for y and said y equals this and y equals that, and you're like, hey, they're the same equation, right? Or at least you'd say, hey, these are the same slopes, different y-intercepts. Well, there you go. It's a parallel line, no solution, right? So each one of these looks something like that. Each one of these, not companies, but this is percentage, this is time. And so this is no solution. Okay. Now on to the easier ones that don't really have any history behind them. I just solve these systems of equations. All right. Now evaluate what you're given. I'm given two lines, right, or two equations of the lines, and one is already in y equals mx plus b form, slope-intercept form. The other one's not. All right. When you're given this situation, this is a prime candidate for substitution, right? Because I can take this value of y and substitute it for that value of y to make 2x plus 3 times the quantity of this negative 5x plus 1 closed quantity, continue equation, equals 12, right? Now I only have one variable in my equation and I can solve for it. 2x minus 15x plus 3 through distribution equals 12. All right. Now I'm going to move this one over here and combine them. So this becomes negative 3. All right, so 12 minus 3 is 9. And then I'm going to get 2 minus 15. 2 minus 15 is negative 13. Wait a minute. It should be 3 times 5. This is a 17. Sorry about that. That was a transcription error. Right, so this should have been minus 17. Sorry about that. So this is 12 minus 17 is negative 5. Hold on a second. I'm making a mistake somewhere. Oh, this is a negative 5x. So this should be negative 5x plus 17. So this would be 3, negative 15, and then 3 times 17. That's where I'm making my problems. 3 times 17 is 51. This should be 51. So it's going to be negative 51 over here. Negative 51 right there. All right, so 12 minus 51 is 39, is negative 39. So negative 3x is negative 39. All right, 39 divided by negative 3 is 13. So x equals 13. All right, so this is 13 right there. Okay, I already have a y value, something in terms of y. Right, so this equation was y equals negative 5x plus 17. I'm going to take this 13, recycle it into my x right here, because that's what x equals. Y equals negative 5 times 13 plus 17. 5 negative times 13. Negative 65. Y equals negative 65 plus 17. Y equals negative 48. Okay? Any questions on that one? Oh wait, not 13, it should be 3. 3. 5 times 3. This is wrong. Some transcription errors here. Sorry about that. So this is negative 15 plus 17 equals 2. Sorry about that. Equals 2. So it's 3 and negative 2. Okay? All right, moving on to this one. Here I have 2 in standard form. When you have 2 in standard form, you look to see if you need to rearrange the equation, or can I multiply one of the equations or both of the equations so that one of my variable terms have the same number. So you find the least common denominator, right? I have a y and a 4, right? They're both positive. And then I have a negative 2x and a 3x. One's negative, one's positive. Well, since I got one negative, one positive, I'm gonna elect to multiply both of them so that they equal, how about 6, right? Or negative 6. All right, so I'm gonna multiply this one by 3. So I get negative 6x plus 3y equals 18 negative times 3, negative 54. Okay, I'm going to multiply this one by 2. So it's going to make it 6x plus 8y equals 10. All right, these cancel out like I wanted them to. This becomes 11x equals negative 54 plus 10 equals negative 44. So x equals negative 4. Okay? Sorry, y equals negative 4. Okay? So now I'm going to recycle this back into one of my equations. I'm going to pick this one because I don't have to multiply y by anything. Negative 2x minus y, right? That's y is negative 4, so plus minus y equals negative 18. I got to solve for x. Negative 2x equals negative 18 plus 4, which is negative 14. X equals 7. Questions there? Rushing through this a little bit so that you guys have time to work on more work. All right, last one. Choose your own adventure. Again, I think I'm going to pick, well, I can solve for y and recycle it and substitute it. I can make y equals mx plus b equal y equal mx plus b, but that's going to take 2 rearrangements of equations. So again, I think here I'm going to use substitution. Right, so least common denominator, I have a negative and a positive there. That's probably going to be my best bet. So I don't have to worry about multiplying anything by a negative. It's going to reduce the likelihood for errors. So 4 and 5, least common multiple between those two is 20. So I need to make this one 20x. So I got to multiply both sides by, I got to multiply everything by 5. Right, so 20x plus 45y equals 15 negative times 5 is negative 75. Okay, and I got to multiply this one by 4. So it's going to be negative 20x plus 28y equals 37 times 4, 148. Okay, that allows me to eliminate 20x and negative 20x. So I have to add 45 and 28. 45 plus 28 is 73y, and negative 75 plus 148 is 73. Y equals 1. Recycle the y. Do it in the blue equation. 4x plus 9 times 1 is 1, or 9, equals negative 15. Bring this over here, negative 9. So this is going to be 4x equals negative 24, x equals negative 6. So 1 comma negative, whoops, backwards. Again, 1 comma negative 6. Negative 6 and 1. Okay, last one. Solve this by graphing. So in order to solve this by graphing, you need to know how to graph. burgundy and blue equations. Burgundy equation starts at my y-intercept at -3. And it's going to go up 3 and over 2. Up 3 and over 2 right there. Okay, so I'll make a line for those ones. And when you're doing it like this, it's really important to be accurate and precise with drawing your lines, because a little angle will throw you off. All right, so there's my equation. Y equals 3/2 x minus 3. Okay. Then my blue equation starts at 4, or starts at 2, and it's 4 over 1. So it goes 1, 2, 3, 4, and over 1. Starts at 2, goes up 4, 1, 2, 3, 4, and over 1 right there. Starts at 2.
Why did it start at 2?
Because my y-intercept is 2. Start your equation on the y-intercept when you have y equals mx plus b. This one started at -3 because the y-intercept for this one was -3. Okay? So now I'm going to take this one here and line it up with this one. And where these two lines intersect is my solution. Right? So you can say that this is going to be -2 and -6. -2 and -6. And if you were to solve for x using setting those to each other, and then plugging, you would have gotten -2. And if you plug that in, -2 in any one of these, you'll get -6. Okay? All right.